In continuation, we were calculating the bond order. Bond order means number of electrons in bonding molecular orbitals minus electrons in anti-bonding molecular orbitals upon 2. So we will calculate the total number of bonding molecular orbitals. The electrons in bonding are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is also among the bonding, sigma bonding. So 10 electrons are there in bonding molecular orbitals and 4 electrons are there in anti-bonding molecular orbitals. So 6 upon 2 is equals to 3. And we know that nitrogen forms 3 nitrogen bond with the other nitrogen atom. So here we are having bond order is equals to 3. Now third thing that is students we are going to discuss from this is about the magnetic nature. So there are two type of nature, that is magnetic nature, that is we can say paramagnetic as well as diamagnetic. Paramagnetic means that is the molecule is attracted towards the magnetic field, and diamagnetic means the molecule is repelled by the magnetic field. So the nitrogen will show paramagnetic or diamagnetic nature. How can we see? If the electrons will be unpaired over here, that means here pairing is there. If any of the electron will be unpaired, that means it will show the paramagnetic nature. But here in the bonding molecular orbital as well as anti-bonding molecular orbital, none of the electron is single. All the electrons are paired. That means nitrogen is diamagnetic because it is having paired electrons. None of the unpaired electron is present. One more thing is there, students. I just want to tell you about the stability. So either the molecule is stable, stability. This we will discuss about the number of bonding electrons. If the number of bonding electrons are more as compared to the number of electrons in anti-bonding molecular orbitals, then that molecule will be comparatively more stable as the other molecules. So we have to compare the bonding as well as anti-bonding molecular orbitals. So student, these are the energy level diagram for the elements up to, for the molecules up to nitrogen. Students, now we will discuss about the energy level diagrams of molecular orbitals for oxygen and fluorine. So how can we draw? We will make a line which represents the increase in the energy, and these this is one of the oxygen atom, atomic orbitals of oxygen, and these are the atomic orbitals of the another oxygen. Both get combined to form the O2 molecule having molecular orbital. So 1s orbitals, they get combined in this way, and 1s orbitals get combined to form the sigma 1s bonding molecular orbital and sigma star 1s anti-bonding molecular orbital. Similarly, the 2s orbitals get combined to form two molecular orbitals, that is sigma 2s molecular orbital, that is bonding, and the second one is sigma star 2s anti-bonding molecular orbital. Okay, now in case of oxygen and fluorine, the 2p orbitals are 2px, 2py and 2pz. These are 2px, 2py and 2pz orbitals, atomic orbitals of the another oxygen. So first of in case of oxygen and fluorine atoms, the 2pz molecular orbital, that is sigma 2pz molecular orbital, is comparatively having lower energy as compared to pi bonding molecular orbital. So first of all, due to lesser energy, the sigma, ये बेटा आप इसको स्ट्रेट बना लेना पूरा, सिग्मा 2pz bonding molecular orbital, it is having lesser energy, so it will be comparatively downward as compared to pi bonding molecular orbitals. But up to nitrogen, the pi bonding molecular orbitals are having lesser energy as compared to sigma bonding molecular orbitals. So this one is the sigma bonding molecular orbital, and one over here it will be the, this one will be the sigma anti-bonding molecular orbital, Okay, and then pi bonding and molecular and anti-bonding molecular orbital, they are having the energy between both these. So the pi bonding molecular orbital, its energy level diagram will be like this. This is pi 2p x and pi 2p y bonding molecular orbital, and these are the pi star, that is pi anti-bonding 2px and pi anti-bonding 2py molecular orbitals. So in this way we are having a skeleton of the molecular orbitals. Now we will fill the electrons. Then oxygen is having configuration 1s2, 2s2, 2p, 4. 1s2, 2s2, 2p, 4. Students, if here O minus 2 is there, you can take minus 2 means 2 more electrons you have to take. So you can draw the energy level diagram of any of the molecule. Either it is O2, either it is O2 minus, either it is O2 plus. If O2 plus is there, then one of the oxygen will be plus. So you have to reduce one of the electron over here, and then you have to fill all the electrons in this diagram. So we will fill 4 electrons are there. So 1, 2, 3, 4. So here 2 and 2. Then 2s4. So sigma 2s2 and sigma star 2s2. Okay, the number of electrons we are filling we will represent over here. Then in case of 2p, so over here 8 electrons are there. So 1, 2, sigma 2p z2, 3, 4, 5, 6, 7, 8, and they are having 2 electrons, they are having 1 electrons. So we will fill the electrons like this. Now students, this is the O2, that is molecular orbitals. These all are the molecular orbitals. Now we will write down the electronic configuration. So electronic configuration will be sigma 1s2, sigma star 1s2 anti-bonding. Then we will write the electronic configuration in the increasing order of their energy. Then sigma 2s2, sigma star 2s2 anti-bonding molecular orbital. Then sigma 2pz2. Afterwards pi 2px2 is equals to, which is equal to pi 2py2, because both the bonding molecular orbitals are having same energy. Then afterwards pi 2p pi star, that is anti-bonding pi orbital, 2px1 is equals to pi star 2py1. So this will be the electronic configuration for the oxygen. Okay, then we will calculate the bond order. The bond order is equals to number of electrons in bonding molecular orbital minus number of electron in anti-bonding molecular orbital upon 2. So how many electrons are there in bonding molecular orbital? The bonding molecular orbitals are 2, then 2, 4, then 2, 6, 7, 8, 9, 10. 10 electrons are there in bonding molecular orbital, and in anti-bonding molecular orbitals how many electrons are there? 2, then 2, 4, 4 and 2, 6. So minus 6 upon 2. So it will be 4 upon 2 is equals to 2. So bond order will be 2, and we know that oxygen forms 2 bonds with the other oxygen atoms. So bond order will be 2. Now students, we will calculate that whether the molecule is paramagnetic or diamagnetic. So oxygen will be paramagnetic because it is having the single electrons in the molecular orbitals. So paramagnetic means it will get attracted due to the electric field, due to the magnetic field it will be attracted. That's why the oxygen molecule over here, it will be, I'm just writing here the points, the oxygen will be paramagnetic. It will be paramagnetic in nature. This is the third point. These are first and second points, and this is the third point. It will be paramagnetic in nature. Okay students, so these are the 3 main things that we have to know. Now students, similarly you can draw the energy level diagram for fluorine and other elements up to fluorine, as well as you can calculate the electronic configuration, bond order also. Now students, a few points are there in the molecular orbital diagrams. That number one is the number of that about the stability. So again I want to stability of molecules. So I want to tell you, if the number of electrons in bonding molecular orbital is more as compared to number of electrons in anti-bonding molecular orbital, then molecule will be stable. Then the molecule will be more stable. So all those molecules in which bonding electrons are more than anti-bonding molecular orbitals electrons, then the molecule will be more stable. And if the number of electrons in anti-bonding molecular orbital is more than bonding molecular orbital, then the molecule will be unstable or less stable as compared to the other one. Okay, now the next one is about the nature of the bond. Generally the bond order, if the bond order is 1, 2 and 3, then they represent that the number of bond between the atoms will be 1, 2 and 3. For example, oxygen, we are having bond order is equals to 2. That means between oxygen atom 2 bonds will be there. So in this way we can calculate the nature of the bond, the number of bonds also. Next one is about the bond length. So one more thing is there, if the bond order increases, then the bond length decreases. That means the bond length is inversely proportional to the bond order. So if we means 2-3 molecules are given and you have to arrange them in the order of their bond length, then simply calculate the bond order. So if bond order increase, then the bond length will decrease. As well as we can also calculate the magnetic nature, that is if the electrons are single filled or unpaired, or we are having any unpaired electron is there, then in that case the molecule will be paramagnetic. And if electrons are paired in the molecular orbitals, all the electrons are paired, then the molecule will be diamagnetic. The paramagnetic means the molecule is attracted by the magnetic field like oxygen, and diamagnetic means the molecules are repelled by magnetic field, as we have drawn the diagram in nitrogen. Nitrogen is diamagnetic, oxygen is paramagnetic. So students, you can calculate the bonding pattern. I want to tell you one more thing. If you are given in the exam, because these energy level diagrams, these all things you have to calculate, and these are very important. So students, if you are given, suppose you are given O2 minus molecule and you have to draw the energy level diagram or bond order also. So how will you calculate? So in oxygen you have to take one oxygen atom and the other oxygen atom you will take O minus. So here you have to take one oxygen and here you have to take O minus. So here you will fill one more electron and then the pairing will be like this. So these are the ways, like if you are having N2 plus, any molecule can be given, so you have to reduce the electron here as well as here like this. You have to write the configuration by adding or reducing the electron as it is given in the ion. Okay, so this is the way by which you can draw the ray diagram. I hope you understand. Students, these are the very important part of the MOT. No one will ask about the bonding pattern, like how the bonding and molecular and anti-bonding molecular orbitals are formed. No one will ask. Everyone will ask about the electronic configuration, about the bond length, about the bond order, about the paramagnetic nature, about the energy level diagram, about the stability. So students, it must be very clear to you.